How are you doing, families of my channel? Welcome to my class. This is the class to calculate empirical formula and molecular formula. Empirical formula means the simplest formula, which is represented by simplest whole number ratios of atoms of elements. And molecular formula is the actual formula in which the formula is represented by the actual number of atoms of elements that must be present within the molecule of the compound. For instance, these are the examples of the compounds formulas. Here, benzene, the molecular or the actual formula of benzene is C6H6, and it is empirical formula when the numbers which are divided by the HCF, their common HCF. Therefore, the 6 by 6, 6 by 6 gives us C1H1, that means CH. Glucose molecule, as you can see, carbon 6, hydrogen 12, O6 is the actual or the true formula of glucose. Therefore, the HCF of 6, 12, and 6 is 6. All these numbers divided by a common number 6, it becomes C1H2 or 1, which means C1H2 or 1. This is the empirical formula of glucose. When it comes to sulfuric acid formula, it is H2SO4. The molecular or the actual formula of sulfuric acid, this one, and the empirical formula is also the same because there is sulfur with one subscript. Therefore, we cannot divide it by any other number. The number 1 by any other number will become fractional number. Therefore, the subscripts of atoms of elements in the formula must be found in whole number ratios only. Therefore, the empirical formula and the molecular formula of this compound is the same. There are many compounds like sulfuric acid, nitric acid, and sodium carbonate, and so forth. There are many types of compounds having the empirical formula and molecular formula as the same. Okay. How can you calculate the empirical formula of compounds? There are to be followed the steps. The number of mole calculation is the first step. For example, question number provided here. Calculate the empirical formula of a compound containing 43.6% phosphorus and 56.4% oxygen. In order to calculate the empirical formula, first step must be done is number of mole calculation. Number of mole means mass given over molar mass or atomic mass of an element. Therefore, the number of moles of phosphorus from this given substance is 43.6 divided by 31 is atomic mass of phosphorus. It gives us the following result. This is 1.41 mole. And number of mole of oxygen is equal to 56.4 divided by atomic mass of oxygen is 16. And the result becomes 3.53 mole. Okay. And the second step to be calculated is we will find the mole ratio, which means all the values, that's the number of moles calculated, must be divided by the smallest number of mole, which is the smallest number of mole is 1.41. Therefore, this number will be divided by itself, and this number will be divided by 1.4. It gives us the mole ratios are the subscripts of atoms of elements that should be found in the formula. Therefore, 1.41 over 1.41 is equal to 1. Any number divided by itself is 1. And 3.53 divided by 1.41 it gives us 2.5. Therefore, this one is a whole number ratio or the relative number or subscript of phosphorus, and 2.5 is the subscript of oxygen. Therefore, the formula of the compounds becomes P1O25, P1O2.5. But here, the number must be converted into whole number because it is fractional number. The subscripts must be whole numbers. Therefore, in order to convert this one into whole number, we should choose appropriate number, and starting from 2 and 3, and any multiplier should be applied. But multiplying by to this number, it will be converted into whole number 5. Okay, therefore this number also, the subscript of phosphorus also must be multiplied by the same number 2, and therefore phosphorus 2 or 5 will be the empirical formula of the compound. This one's question 2. The compound contains 79.9% carbon and 20.1% hydrogen. What is the empirical formula of the compound? Okay, number of mole of carbon is equal to given mass over atomic mass of carbon 12, which is equal to 6.7 mole. And number of mole of hydrogen is 20.1. This is given mass over the atomic mass of hydrogen is 1. Therefore, 20.1 is the mole value of the hydrogen. Then which one is the smallest value? 6.7. Therefore, all the values must be divided by 6.7. For carbon becomes 1, and for hydrogen, the mole ratio becomes 3. That means 20.1 divided by 6.7 is equal to 3. Therefore, the empirical formula of the compound, that is carbon 1, hydrogen 3. This is CH3. This is the empirical formula of the compound. How can you calculate or form the molecular formula of the compound? Is given by, you can apply this formula. Molecular formula is equal to molecular formula mass divided by empirical formula mass, and the result multiplying the empirical formula of the compound. This means it gives us as the molecular formula of the compound. Okay. Question number 3. The compound ethylene glycol contains 38.7% carbon, 9.75% hydrogen, and the rest oxygen, which means the oxygen mass percentage is equal to 100 minus the summation of these two numbers. Okay, mass of oxygen is equal to 100 minus 38.7 gram of carbon plus 9.75 gram of hydrogen, which is equal to 51.55 gram. This is the mass of oxygen. Then the number of mole of each atom of element will be calculated as follow. Number of mole of carbon is equal to mass given of carbon, is this one, over atomic mass of carbon 12, which is equal to 3.22 mole of carbon. Number of mole of hydrogen is equal to 9.75% of the hydrogen given mass over the atomic mass of hydrogen is 1, which is equal to 9.67 mole. And number of mole of oxygen is equal to the mass percentage of oxygen 51.55 divided by atomic mass of oxygen is equal to 3.22. Which one is the smallest number of mole is this one and this one. That means belonging to carbon and oxygen having the same result or similar, almost the same result. Therefore, we'll divide all the values by this ones. It becomes 1, but this one becomes the another number which is nearly 3. This one becomes 1. This is the formula of the compound. Looks like the following. This is 1, 3, 1, which means the empirical formula of the compound, which is composed of carbon, hydrogen, and oxygen, it seems like this one is carbon 1, hydrogen 3, and oxygen 1. After you got the empirical formula, you will apply molecular formula is equal to molecular mass over empirical formula mass times empirical formula. Okay. and the empirical formula must be determined from this formula. That means carbon 12, hydrogen 1 times 3 plus oxygen 16 gives us 31. The empirical formula of the compound, this one's compound, is equal to 31. The molecular formula of the compound is equal to molecular mass given. The molecular mass given is 62.07 gram divided by 31 times empirical formula of the compound. This one is okay. Therefore, this one 62.07 divided by 31 is nearly 2 times this formula gives us the molecular formula. That means 2 times C means 1, C1, C becomes 2, hydrogen becomes 6 because 2 times 3 is 6, and oxygen becomes 2. This is the molecular formula of the ethylene glycol. Question number 4. Calculate the empirical formula of the following given us. That means sodium and chlorine are given with 39.3% and 60.7% respectively. Therefore, what is the empirical formula of the compound formed from sodium and chlorine? That means number of mole first must be calculated and the mole ratio will be followed. Number of moles of sodium is equal to given mass of sodium 39.3% and atomic mass of sodium is 23. Therefore, 39.3 divided by 23 is equal to 1.7. And number of moles of chlorine is equal to 60.7 divided by 35.5, which is equal to 1.7. Therefore, both are the same in number. That's 1.7, 1.7. Therefore, dividing by 1.7 divided by 1.7 becomes 1. Therefore, the formula of the compound, the empirical formula will be Na1Cl1. That means NaCl. It becomes NaCl. Okay, this is the calculation to find for A. Okay, what about B? This is potassium given, carbon given, oxygen given. What is given mass given of potassium 56.5% and carbon 8.7 and oxygen 34.8. Therefore, number of mole of the potassium is equal to given mass over molar mass of potassium 39, which is equal to 1.45 mole. And the number of mole of carbon is equal to given mass means 8.7% divided by atomic mass of carbon means 12, which gives us 0.73. And number of mole of oxygen is equal to given mass of oxygen 34.8 divided by the atomic mass of oxygen is 16, gives us nearly 2.18 mole. Which one is the smallest number of mole? Is this one is belonging to carbon. That means 0.73. Therefore, all the values must be divided by 0.73. And the mole ratio of potassium is equal to number of mole over the smallest number of mole, which is equal to nearly 2, and mole ratio of carbon is equal to 0.73 divided by itself 1, and mole ratio of oxygen is equal to 2.18 divided by 0.73 is equal to 3. Therefore, these are the subscripts of numbers, that is 2 belonging to potassium, K2, C1, O3. That means K2CO3 will be the empirical formula of the compound. Okay, question number 5. A compound, there are 2 questions belonging to this. A compound of carbon and hydrogen contains 92.3% carbon and has a molar mass of 78.1 gram per mole. What is this molecular formula? First of all, the compound is composed of carbon and hydrogen, containing carbon percentage is 92.3 and hydrogen percentage is equal to 100 minus this value, which gives us the number of the mole or the percentage of the hydrogen, okay. Therefore mass of or mass percentage of hydrogen is equal to 100 minus 92.3, which is equal to 7.7%. Therefore, first step, number of mole of each atom must be calculated. Number of moles of carbon is equal to given mass over 12, that is atomic mass of carbon, which is equal to 7.7 mole. And number of mole of hydrogen is equal to 7.7 divided by 1. The 7.7 is given mass of hydrogen in percent, divided by atomic mass of hydrogen 1, which is 7.7 mole. Therefore, having the same number of mole divided by 7.7, both becomes 1, 1. Okay, therefore, the empirical formula of the compound will be 1, 1. That means carbon 1, hydrogen 1. The empirical formula mass is equal to mass of carbon 12 plus 1 is equal to 13. And the molar mass of the compound given is 78.1 gram per mole. Therefore, to find the molecular formula of the compound, we will apply molecular mass over empirical formula mass times empirical formula. Molecular mass means this one's, empirical formula mass means 13. Therefore, 78.1 divided by 13 gives us the following. You see, this one becomes around 6. Okay, 6 times the empirical formula of the compound becomes the formula of the compound. So you can see, you can write this one 6 times the empirical formula means 6 times carbon is 1, hydrogen is 1 inside the bracket. Therefore 6 times 1 means 6, and 6 times 1 for hydrogen also is 6. This is the molecular formula of the compound, which is calculated in this way. And question number 2, that is B, sorry, under question number 5b, mass of carbon given is 24.3%, and mass of hydrogen is equal to 4.1%, and mass of chlorine is equal to 100 minus the summation of this value. This gives us 71.6%. Therefore, number of mole of each atom of element will be calculated as given mass over atomic mass of each respective atom of element gives us number of mole of carbon 2, and hydrogen is 4.1 because 4.1 divided by atomic mass of hydrogen is 1 gives us 4.1, and that of chlorine is given mass 71.6 divided by 35.5 is the atomic mass of chlorine, which gives us 2. Therefore, the mole ratio will be calculated by dividing the smallest number of mole is 2. 2 by 2, 1. 4.1 divided by 2, nearly 2. This 1 by 2 is 1. Therefore, the formula should be CH2Cl is the empirical formula of the compound. CH2Cl, CH2Cl, because mole ratio is 1 to 1. Then the empirical formula of the compounds, this one's. The empirical formula mass is 1 carbon, 2 hydrogen, and 1 chlorine. That means 12 plus 2 plus 35.5 gives us 49.5. Okay, and the molecular mass or the molar mass of the compound given 99 gram per mole. To find molecular formula, you can apply molecular mass divided by empirical formula mass, and the result multiply empirical formula. The empirical formula is this one, CH2Cl. The molecular mass 99 divided by empirical formula mass is 49.5. This one divided by this one becomes 2. 2 times carbon, 2 times hydrogen, 2 times chlorine. That is the formula of the compound will be C2H4Cl. Okay, the formula, the molecular formula becomes C2H4Cl, like this one. You see, this is 1, this one divided by this one, 2. 2 becomes multiplier of this ones. The result will be as follow. The result will be C2H4 Cl2. Okay. Do you have any question? You can ask me. You can write your comment, share and like. Don't forget. This is a class.